Hi, I'm Gary Flispart. I'm standing on the campus of Indiana University Southeast in New Albany, Indiana. As a member of the IUS Astronomical Society, I help maintain and operate the astronomical equipment on campus. The facility you see behind me is the 16-foot ash dome, which was donated under a grant pursued by now Professor Emeritus Dr. Gerald Ruth of Earth Sciences and longtime astronomy educator on the campus.
With all domed observatories, the telescope inside must look outside at the heavens through an opening in the dome called the shutter, which opens to the point where you can look anywhere from the horizon to the zenith, but only opens a couple of feet wide. You have to, in order for the telescope to be able to see in many directions, the dome must be rotated as needed to allow an opening in the direction the telescope is pointing. Okay, now for a quick tour of the observatory. You open the door. I have the dome open. You see the shutter. It's open, with the opening about 2 feet wide. In the center of the room you see the instrument, the telescope, in its normal parked position when it's not in use. The instrument now in the observatory, the primary instrument, is an Celestron Edge HD Schmidt-Cassegrain telescope. It has a secondary instrument for wider field stuff, a Takahashi 4-inch apochromat. The pier was designed and built by one of our IUSAS members, Joel McAvoy, who's an ace professional welder. Did a really good job. It was originally built for the original instrument in the space, which was a 7-inch Meade refractor with a smaller amount of smaller weight. The pier is so good that it's easily held the weight of this new instrument, which is twice the weight at least of the original instrument. This new equipment was generously donated by Dr. Gerald Ruth on his retirement from IUS a couple of years ago. The dome controller controls, the original controls are here. I have a switch on my relay box. If I flip the switch to manual control, you can see in here as the dome rotates. If I switch it the other way, it goes back. This is how we've been operating it as a matter of course for a long time. But however, if I switch it to remote, this control box, which is based on a Raspberry Pi with a touch screen, will be able to, if I can enter in an azimuth position. Right now it says 189 is the current position. If I put in, say, 150, enter, it will then try to slew. Oh, I accidentally entered 15, so I'm going to say stop. Okay, I'll try that again. 140, hit enter. Telescope will slew until it reaches within 4 degrees of 140. There's a little bit of inertia to take into account, so I stop it within 4 degrees. And usually it'll get close to its original spec. The way that the dome determines its position, you'll notice barcodes around the perimeter of the dome every 3 degrees. Code 3 of 9 barcodes. Inside this box is a barcode scanner. which connects through cable to the Raspberry Pi computer as a keyboard. It looks like a keyboard to the program. The program reads the keyboard, the numbers scanned, and uses that to determine the position. And the GUI provides me an alternate to a keyboard to enter data to put an azimuth specification in. But on top of that, there is a wire that connects the serial port over to another computer. And just to demonstrate with a serial protocol program, in this case PuTTY, it's a serial terminal emulator. If I type in the command that it's expecting, I'm attempting to emulate a Digital Domeworks dome. So if I type in a GINF command, it provides a string of data that it's expecting to see. In addition, over the top of it, it just wrote its current position, which is 144 on the azimuth. If I now type in a command to go to, which is G followed by 3 digits, if I say go to 220, then the dome starts to slew. On the screen, you see the 220, and on the wall, when it reaches 220, it should stop. It stopped when it passed 216. So that demonstrates that it is capable of doing a serial protocol control from another computer. This is still in an alpha stage of the project because the intended control program on Windows is the ASCOM stack of drivers and protocols, which allows me to connect a variety of telescope equipment at the same time through the same computer. If I press Connect Dome, it is connecting to the same dome. But apparently I need to debug the protocol to some extent because it seems to be exhibiting bad behavior here. If I type in a 130 to this field, the field for a go-to, and then I press the go-to button, it doesn't seem to do anything until I press disconnect dome. Then all of a sudden the dome takes off. So it received the information, and as you see on the screen, showing the 130, and it's attempting to slew to 130. But I have some work to do yet on debugging the protocol because it's almost working, but not quite. But it will get to that 130 and stop. So, at some point, I should be able to control both the telescope and the dome from the same program on a PC under Windows using the ASCOM stack, in addition to another program such as SkyCharts. Cart to Sail, the SkyChart program, is capable of controlling an ASCOM stack and running both a telescope and a dome, and in addition things like a camera and a microfocuser. So I still have work to do, but after 14 years I'm glad to say I finally have a computer installed which is capable of controlling the dome both manually and automatically remotely from another computer.